Cool. So thanks everybody for joining me. Thanks for filling out those poll questions too. It sounds like we got the perfect audience for the topic and the level that we're going to go through today. Because today we're going to talk about an introduction to Azure Stream Analytics. We'll go through the agenda here in a second, but first a little bit about myself. So I'm a principal consultant here with Pragmatic Works. There's my contact information up on the slide. If you guys have any questions, anything like that after the webinar, feel free to reach out to me. So I'm bgall@pragmaticworks.com. I do have a blog, bradgall.com. I'll go ahead and put the slide deck up on the blog site probably by tomorrow, so everybody can have a chance to download that if you're interested in that. And also I'm on Twitter at bradgallsql. So a little bit more about myself. In case you haven't seen me speak on Pragmatic Works free trainings before, I've been working with Microsoft Data Platform for over 10 years now. I like to speak at user groups and webinars whenever I can get a chance to. Me and my wife and 2 children, we reside here in Jacksonville, Florida at the headquarters, right near the headquarters of Pragmatic Works. And I am a diehard Packer fan. Can't wait for football season to start up here in the next few weeks. Now let's talk about our agenda for today. So we're going to talk about real-time analytics via Azure Stream Analytics. So we're going to start with a quick overview with some slides of really what real-time analytics is. And then I'll talk about how we're going to get started accomplishing real-time analytics by using Azure Stream Analytics. We're going to be pretty demo heavy today. So we're going to kind of just do a crash course through what you need to set up a Stream Analytics a demo, a POC, if you will. So we're going to do that real quick with a demo set of data and an application that Microsoft actually gives us on their website. So I'll also share that link in case anybody is interested in setting this up on your own within your environments. You'll definitely be able to do that by the end of this presentation today. And then of course we'll follow up with some questions at the end. So we're going to start with an overview of real-time analytics. And really we start with, what does real-time really mean to you? So I have conversations with customers all the time. I'll be scoping out projects with them, and the question of real-time usually comes up, and a lot of times there's some confusion around that. I'll get things like, yeah, let's throw real-time in there if we can, or as near to real-time as we can, or the business says they really want real-time. Now us as technology experts, really we needed to boil down what they mean by that and what we can give them, what technologies are available for us to accomplish those goals that the business is asking us for. So in those discussions, we really kind of have to nail down, what do they mean when they say real time? Do they mean within the hour? Do they mean when they say near real time, what does that really look like? Or do they really need real time live data? So our options for accomplishing those different levels of real time come down to traditional analytics, which we'll talk about here for a second, or what we're going to demo today, which would be like live data and stream analytics on data as it's in flight. Now, if we're talking about real-time analytics, basically I just want to be able to process not within a nightly batch processing, but maybe within an hour. Usually we can still handle that with some type of batch processing, a traditional data warehousing or data mart scenario, where we are landing data into a database and then querying data that's static within that database. So we'll traditionally handle that with SSIS or tools like that. Now, to get closer to real time, what we do with some clients would be something like replicated data, or maybe some SSIS packages that are really simple and just pulling over data as quickly as possible, and maybe every 5 minutes, like micro batches into an ODS or something like that. That's a scenario where we can get data even with less time to report than an hour. Maybe we can get down to 5 minutes or something like that, and that would be a near real-time scenario. Now in that scenario, we're still landing data within a database, and we're querying that data out of that database. So it's static data that we've landed into a database. It's within our B tree structures, log files, all those type of things. Now what we're going to talk about today would be live data stream analytics. There's a big architectural difference between the first 2 scenarios I described and what we're going to go through today, which is Azure Stream Analytics. Now with Stream Analytics, we're actually capturing the data in flight before we land it into a database. So we're going to query the data as it's coming out of our application or as it's coming out of our devices, give some real-time insights into that before we land it into the database. So that's the key difference here when we talk about Stream Analytics or Azure Stream Analytics or Apache Storm, things like that. Here's a diagram that kind of illustrates this for us. So as we are, actually one sec, let me turn on my Zoom it. Open this back up. So as we are pulling in data from our streaming events, so we're using either clicks from a website or sensor readings or maybe just an application pumping data into our Stream Analytics, we're going to run what's called a continuous standing query on that data set. We're going to look at what that means, but basically with a Stream Analytics solution, we're going to create a query that is constantly ran against the data as it streams through our event hubs. We're going to push that real-time continuous result set to our users, and we can do that a number of ways. The way we're going to do it today is we're going to push it to a Power BI dashboard. And so what that'll give our users is a real-time view of the data as it's flowing through within a Power BI dashboard. We can also pull in some static reference data to relate to those streaming events if we'd like to. We're not, just for sake of time, we're not going to pull that in today. And then we can also take that the data set and also either discard it, or usually we want to archive that into something like a data lake or a blob storage. So we're going to, time permitting, look at that as well and have two outputs. We're going to output to a Power BI streaming dashboard, and also we're going to dump the data into a blob storage so that we have that archive to do some additional analysis on it, maybe pull it into our warehouse and pull it into those traditional analytic warehouses that we're used to and that provide value for looking at large volumes of data over history. Now, what are a few scenarios that we can use real-time analytics? There's some traditional options out there, some things to think about. Really what we want to talk about right now is we're going to go through the tool today, but what are the business cases that this tool can solve? Now, one of those things is something called the Internet of Things. A lot of people have probably heard of this by this point, and we're helping a lot of clients set up Stream Analytics and Internet of Things scenarios. And they can do things like tell us when we need to deploy help for a failing windmill. So we have a device set up on the windmill that's constantly streaming data, and we can capture those metrics and realize whenever a windmill is about to fail and try and get out there to do maintenance on that windmill before it fails to keep things up and running. We can determine real-time adjustments. So we have smart meters now on houses, so we can see how much power is being consumed and where we need to flow power or turn up generator output, things like that. I mentioned predictive maintenance on the windmills, but even on your shop floor, we can do readings from devices on your shop floor and see pump them through a predictive maintenance algorithm to determine, hey, it looks like this piece of equipment needs a particular type of maintenance before it fails, so we cut down on our downtime and get some return on investment out of our solutions. Some other use cases are just for monitoring activity. So maybe in your store, you're trying to monitor how much product you have on the shelf at Christmas time. You have product back in your inventory in your warehouse, but maybe as the shoppers are coming in and streaming your and hitting your store, you need to monitor how much is left on the shelf via your point of sale system, streaming that data to your shop floor so they know what products they need to get out there and how fast. This again is going to give you some return on investment of keeping those shoppers buying your products as opposed to you had the product sitting back in the inventory, it wasn't on the shelf, and now they've gone somewhere else to purchase that. We can also monitor issues within our infrastructure. So we can have applications that would pump data that monitor things like temperature or CPU throughput on our infrastructure. Maybe we need to add some new, scale up some clusters to handle throughput of what's coming through. We can handle website clickstream data. So maybe we want to watch what users are clicking on through our website, how much time they're spending on a particular website, and maybe deliver some content to them based on that, or alter the navigation of our website based off of the habits that we're seeing happen within our website. And then a very popular one would be fraud detection. That's what we're going to look at today in our demo. Actually, we're going to set up a quick demo of detecting fraud of SIM cards within cellular phones. So we can monitor live what is coming through our application and then look for activity that looks suspicious to us so that maybe we can set up an alert, turn off that SIM or something like that. And then another scenario is just writing an application that just streams lots of data and that we want to aggregate it in real time. So a perfect example of that would be all of the reality shows everyone loves. We're going to build an application, millions of people are going to vote in real time. We're showing on the screen who's winning, who's up, who's down. We see this with sports a lot of times now too. Take polls during sports, you'll see sports apps on your tablet where people are just voting on certain things and stuff like that. And we're going to aggregate all that in real time. So getting started with Azure Stream Analytics. So Azure Stream Analytics is a product from Microsoft that allows us to set up a real-time analytics platform within your environment. We do all this within Azure. So this is a platform as a service solution. And with all things Azure, there's lots of options out there. So one of the things I want to start with talking to you about is why you would choose maybe Stream Analytics over the other offering within Azure, which would be HD Insight Storm. So we do have multiple options to handle real-time analytics, even as a platform as a service within Azure. Today we're going to look at Stream Analytics, but we're going to compare the two right now. So both are platform as a service. If you're not familiar with platform as a service, basically it means that Microsoft is going to handle all the patching for us, all the infrastructure updates. We're not going to deal with servers. We're going to deal with the platform and setting up our code to run on their platform. The key difference between Stream Analytics and HD Insight Storm is that Stream Analytics is a Microsoft proprietary offering that they've built for us. It's going to use something called SASQL. So it is a language that's really similar, I should say, to T-SQL. And what that gives us is a faster learning curve to get set up with Stream Analytics. If you're coming from a SQL background, it creates a familiar environment for us code-wise for what we are going to write to set up our Stream Analytics jobs. Now on the HD Insight Storm side, HD Insight Storm runs on Hadoop, so it's on the Hadoop open source platform, which there's lots of resources out there for Hadoop and HD Insight Storm. The difference there is that it's going to require some Java scripting or C# scripting, and the advantage you get out of that is you can create your own custom code. You can create your own inputs, outputs, user-defined functions. We get some of that capability within Stream Analytics, but not quite as much as we get in HD Insight Storm. So that's kind of your differentiator between which of these two platforms you'd like to use. Maybe if you have Hadoop resources in-house already, you're familiar with Java and C# and comfortable in that environment, HD Insight Storm might be the choice for you. Today, though, we're going to talk about Stream Analytics and walk through a demo of how we set that up. Now, this is an overview of Stream Analytics and just all the different pieces that go together to create a Stream Analytics solution. So over here on the right-hand side, we have, and I apologize, my Zoom it doesn't like me today, so we'll skip that. So over on the right-hand side, we have applications and devices and gateways. So we have some mobile phones, we might have some IoT devices. They're going to stream data into one of two things, either an event hub or an IoT hub, and we're going to talk about the difference between those two here in a slide here in a second. That data is going to flow into our Stream Analytics job. So in our Stream Analytics job here in the middle, we're going to consume the data that's flowing through our event hub that's come from our application or our device. We can also pull in some reference data, like I said, to join to that. Another thing we'll talk about somewhat, but we won't be able to demo today, is we can apply some machine learning functions to the stream as it's coming through. This creates a lot of possibilities for us to be able to run some machine learning algorithms on the data as it's flying through our Stream Analytics job in real time and produce results in real time. So we're going to create an event hub, we're going to create a Stream Analytics job, and then we're going to output the output of that Stream Analytics job to Power BI in our demo today, but we can also archive it to long-term storage for some later batch analysis. We can also pass it to another service bus, another event hub if we'd like, that would then trigger some automation and workflows based off of again, the analysis we do on the data as it's streaming in. So a scenario there might be that because a particular device is failing, maybe we need to turn off some other devices so that we don't overwork our system, or we need to trigger an event in an application that tells our warehouse staff that we need to get a pallet of material out onto the shop floor because we're running low in inventory, things like that. So this is just another view of the architecture. What I wanted to point out here is what we're going to build today. So today we're going to build an event hub. So we're going to build in Azure an event hub. We'll set it up from scratch in Azure. Then we're going to build a stream analytics job. And within the stream analytics job, we're going to transform some data. So we can do aggregations and projections. We can correlate data here. We're going to do a little bit of that with one of our queries. And then finally, we're going to output the query data out to an output within our stream analytics job again. Now, the first step there was creating an event hub. And this is where you need to make a key decision of which of the two event hubs you'd like to use. So you'll see in documentation, event hub or an IoT hub. Really, the biggest difference between these two is if you're dealing with devices and you need two-way device-to-device communication. So with an IoT hub, there's actually capabilities to talk back to devices and send them firmware updates or tell them to do something to the device, shut it down, ramp it up, change settings on the device itself. That would be handled with an IoT hub and an IoT solution. You're not going to have those capabilities in an event hub. Event hubs are just consuming data as it's streamed through. So it could be used for devices or also applications that are just streaming data through to us. Security is a key differentiator between the two. With the IoT hub, we have per device security. So each device is authenticated individually, where with an event hub, we're going to have a primary key token that we're going to put within our application that gives it access to publish to our event hub. So in scenarios where you have lots of devices, maybe even have consumer devices, obviously we're going to go with IoT hubs so that we can keep security down to each individual consumer device. And then the other difference is the scale of the two. So IoT hubs will scale much larger than an event hub if so needed. Now I mentioned that Azure Stream Analytics uses a language called SASQL. So this is a quick look really of what the functions we have available to us within SASQL. Hopefully it looks familiar to you if you're a T-SQL person. It's just a select from, where, group by, having. We have most of the DML that we would expect to be there. We can do aggregate functions, datetime functions. And right there in the middle is where we get a lot of power with SASQL, with these windowing extensions and temporal functions. So we're going to look at what these windowing extensions do and how we're going to use them within our SASQL queries within an Azure Stream Analytics job. Now, one of the things to keep in mind with data as it's flowing into an Azure Stream Analytics job is that all the data needs to have some sort of timestamp on it, because we're streaming data in real time. Everything needs to have some type of time element to it. So either our data source is going to have a time element, and we're going to use that timestamp that's within our data source. In that case, we would have just a select star from a Twitter stream is what we're going to use as an example within our slides here. Or we're going to create a system timestamp where we're going to add our own timestamp. As the data comes in, we'll timestamp it as the data comes in. That could be another option. Now, those windowing functions I mentioned earlier, we're going to take a look at those three that we showed on the slide, and so you get an idea of what we're trying to accomplish as we query the data coming into our Azure our Stream Analytics job. So one of the scenarios might be, we want to tell me the count of the number of tweets per time zone every 10 seconds. This will be an example of a tumbling window, and this is an example of what the query would look like. So we're going to select the time zone. We're going to do just a count star aggregate from our Twitter stream, and we're going to timestamp it by a column that's within our Twitter stream data set. And then we're going to group by and then use the tumbling window within our group by statement. So in this scenario, we're grouping by a tumbling window of every 10 seconds. With the tumbling window, your data events will not cross over windows. So every 10 seconds, you'll get a new window, and we're going to count of tweets that happen within each of those windows. Now with a hopping window, this is going to happen with this scenario, what we're going to try and accomplish is every 5 seconds, tell me the count of tweets that I had for the last 10 seconds. So the best way I can describe this scenario is like a rolling 12-month window with larger set of data. So really, we're just going to do a rolling 10-second window every 5 seconds is what this query will give us. So it kind of smooths out the trend of the data, what that number is going to give us. And what can happen then is that the windows overlap each other, and so an event might actually fall within two distinct windows. And then the last scenario here is a sliding window. So this would be when you would say, give me the count of all the tweets that are tweeted for more than 10 times over the last 10 seconds. So basically every time this runs, it's going to be the last 10 seconds constantly. So the window is just constantly sliding over. That's why it's called a sliding window. And every second, you're going to get the last 10 seconds of data. Now, another thing we can do within Stream Analytics queries is join multiple data streams together. And this is a scenario we're going to use with our data set. So in this example, this is a Twitter data stream. And we can do something with Twitter where we look at the sentiment score, basically, of the tweet. Basically, by reading what the tweeter said, are they happy about what they're tweeting about, or are they unhappy with what they're tweeting about? And by joining the stream to itself, we're doing a self-join in this scenario. It's going to be similar to what we're going to do for our fraud detection. We're looking at, in a 1 minute window, did they flip-flop? So did they, a minute ago, say something that was negative and then flip-flop, and now they're saying something positive. So something's up, there's an anomaly with this person and what they're tweeting about here. The way we do that is we join with the, we use a date diff function, which is slightly different than what you would expect within TSQL. It operates differently here within SAQL. And we're going to use that with a between. So between 1 and 60 seconds, the date diff between those two different tables, which is really just the Twitter stream self-joined on itself. Another option we have within SAQL, like I mentioned before, is Azure Machine Learning integration. Now, this is outside of scope for what we have time for today, but one of the things we can do with Azure Machine Learning is take our machine learning models, our predictive models, and turn them into web services. So again, this is a platform as a service from Microsoft. So we can take a model after we've scored it and we've trained it, we have a good model that we like, we can turn it into a web service, and then Stream Analytics, Azure Stream Analytics allows us to create a function based off of that web service. So here's another example of, instead of doing the sentiment score within our application, if we didn't have that available to us and we wanted to do a sentiment score based off of an Azure machine learning algorithm, we can pass a function. We've created a function here called sentiment. We're passing it the text that is coming from our streaming data source, and we're going to score that via that machine learning web service. So what we're going to do now is jump into the demo. So how do we create and achieve real-time reporting? You'll see we're going to do a quick and dirty setup of this. There's obviously a lot more settings that we could get into, but we just want to give a soup to nuts. Here's some streaming data and pull it into a couple different sources. So we're going to create an event hub. If you're doing IoT, you would configure your devices. We're going to skip that for today. But then within our Stream Analytics, we're going to create an input, we're going to create a query, and we're going to create outputs, and then hopefully get into a Power BI report as well. So let's jump over to that demo. All right, so hopefully you have an Azure subscription set up. That's what's required for an Azure Stream Analytics setup. And what we're going to do first is create our event hub. So I'm going to click this plus sign up here on the top left. They have all the different options grouped differently here within Azure. So I'm going to go to Internet of Things, because I know that's where I can find event hubs. IoT Hub is also here, and this is also where we're going to find our Stream Analytics jobs. So the first thing I'm going to do is create an event hub. I'm going to give this a name, so I'm just going to call this BGAL stream-demo. For the pricing tier, if I click on this, you'll see there's two different pricing tiers. Really, the difference between these two is how much you want to scale up and how much data this event hub can handle. So this is an event hub where my application is going to pump data. I'm just going to knock it down to basic because for our demo purposes, that's pretty much all we need. You can see the pricing. They give you some estimated pricing here on the two different options. So this is going to cost me $11 a month if I leave it on. And then it's also going to charge me 2 cents per million events that are ingressed, that are pumped into this event hub. I'm going to create a resource group. So a resource group is a way to organize objects and services that you set up and stand up within Azure. So I'm going to create one here. I'm going to call this BGAL Stream Demo as well. This one I'm going to call Event Hub, Event Namespace. So I know what I've created there. So actually what I'm creating right now is an Event Hub namespace, and we'll create hubs within it. So this is going to be called BGAL Stream Demo Event Namespace. I'm going to create a new resource group called BGAL Stream Demo. Spell that correctly. So location, we're just going to pick East US 2, and throughput units, I'm just going to leave at 1. This is how you can scale your Event Hub to handle more data. Again, for today, for our purposes, 1's going to be good enough. I'm just going to click Create on this now. So I'm going to click Create. This is going to go out into Azure and spin up my Event Hub. You'll notice here under Activities, it says Deployment in Progress. This is deploying my new resource to BGAL Stream Demo. Hopefully this only takes a minute, and once it's created, we'll pop open that namespace, and then we're going to create our hub. And if it gets too long, I have a working demo set up that we can just fire up. We'll give this another minute. There it goes. So the deployment's successful. I'm going to click on that. You can see now I'm in my BGAL Stream Demo event namespace. We have some options here. This is basically the setup that you'll see with anything you set up within Azure. This is called, they call it blades. So I have my properties and the event hubs that are on this namespace. Next step I'm going to do is create an event hub. So I'm going to click Event Hub. I'm going to name this one BGAL Stream Hub. I can set up different partitions. So again, this is a setting for helping you scale your Event Hub to handle more data flow. Message retention, I'm just going to leave all these as defaults right now. Time window and minutes, all that I'm going to leave as default. And I'm just going to say Create. So that's creating my Event Hub now. And again, once that's created, we'll click on that. There's one more piece I need in the Event Hub, and that's to set up a security policy. So now that I have that Event Hub created within that namespace, I need a way for my application to be able to pump data into that Event Hub. So what I'm going to do is click on Shared Access Policies over here in the settings, and I'm going to add a shared access policy. Call this again BGAL Stream Policy. And I'm just going to give it everything just to keep things simple for us again today. Again, you have some options there where this policy is only allowed to send data to it or just listen to it, or we're going to go ahead and let it manage it. And that's going to create a new SAST key for us. So I'm going to click on that policy now that it's created. And now what I have is a primary key, a secondary key, and a connection string that I can copy out. So we're going to grab the primary connection string. They always give you two within the Azure services, a primary and a secondary, so that you're able to change the keys later on if necessary without having to take your service completely down. So I'm going to click copy on that. What I'm going to do is pull this out into a text file because we need this to configure our application. And I'm going to paste this here. So with our application, the way we configure it within our config file is actually, I need two pieces out of this string. Excuse me, this part gets a little confusing within the demo if you walk through this from Microsoft. What I need to strip off here is this entity path. So this entity path equals is actually a key value pair that gives you the name of the event hub that we're working with. So I'm actually going to, I need to strip off that semicolon as well. So I'm going to cut that off, paste that there, and delete it. So I have that as my event hub. And then I have a connection string that I need for my application. So now that I have that data, I'm going to save it so I don't lose it. What I'm going to show you next is our application. configuring this application. So what we have for our scenario, for our test scenario, is a telco generator. So this application is actually going to create fake calls, like we're going to act like we're all working for a cellular company today. And this is data that's streamed out about calls that our end users are generating. Now I'm going to configure my application here by altering this exe.config. I'm just going to use Microsoft Code to update this. And what I'm going to do is paste those two strings that I pulled out of my Event Hub and place them into my config file here. So one goes there, one goes there. Nope, I did not copy it apparently. Let me try that one more time. There we go. So we have our connection string and we have our Event Hub name, and we're going to save this. Close it down. And then what I'm going to do is I already have a command prompt window open. I've drilled down to the folder where I have my telco datagen.exe. I'm just going to fire up that application and have it start generating some data for us. So I have a little command line that I can run. So we can see this start streaming some data, and it should fire up here in a second. And we'll see this is going to start pumping out call data like it's a demo application basically for the call streams, call data. So that is now pumping out data and is pushing it out to our Event Hub. So we should see on our Event Hub now some data start flowing in here momentarily. So we'll let that run for a second. We should start seeing some incoming messages and things like that. There it goes. So it's spiking up now a little bit. Now that we have data flowing to our Event Hub, the next piece I need is we're going to do what we are all here to talk about, is create our Stream Analytics job. So to do that, I'm going to click the plus sign again over here under Microsoft Azure. I'm going to go to Internet of Things, and we're going to create a Stream Analytics job this time. So the job name for this one is going to be BGAL call stream demo. Stream Analytics job. Let's do that to keep it different. We're going to use an existing resource group. So I created that resource group on the first step. I'm going to associate this this object with that same resource group. It makes it easier for me to clean this up afterwards, and we're going to put it in the East US location. I'm going to click Pin to Dashboard so it's easier for me to find on my dashboard within Azure. I'm going to click Create, and you'll see it's gone out and started creating my Stream Analytics job now. Okay, great. So now my Stream Analytics job has been created, and you can see we have some information about the job. And then we have these three buttons, if you will, within the middle. So we have the inputs, our query, and our output. So I mentioned those are the three things we're going to set up within our Stream Analytics job. The first I'm going to click on is inputs. So I'm going to click on input, which will show me all the inputs that are available right now on this job. I'm going to click add to add a input. We are going to call this call stream. It is a source type of data stream. We're going to pull it from an Event Hub because that's the Event Hub we just created. We're going to use an Event Hub from the current subscription. BGAL Stream Demo Event namespace is what I called my namespace. There's the Event Hub that's within that namespace that I want to use on this job. There's the policy that we created specifically for our analytics. And that should be it. So we're just going to go ahead and click Create on that. Hopefully I didn't miss anything, and we will create a stream input. Sweet, so it created that, it tested it out, everything was successful. Next thing I'm going to do is come over to a query, And we're going to start taking a look at what a query looks like now with that SAQL language. So I have a few queries that we're going to copy and paste just to save some time again from our data, or from our stream source. The first is just going to be a pass-through query. So simple as this, we can do this, call stream. We can write a query just like that. So this data, this query is just going to select star from our call stream. Now, one of the things we can do when we're working with Stream Analytics within the Azure portal is give it some sample data so we can test out our queries and see what the data looks like on that. Now, to do that, I'm just going to click this ellipsis next to the input. I'm going to say sample data from input. So we can give it a few different options here. How many days do we want it to go look back, or hours? We're just going to set it for 1 minute for right now and say OK. And this is going to create some sample data for us. And once that sample data is created, we're going to go with select star from call stream, and we're going to click test. One moment. I added a. Let's try this now. There we go. So I added a dash in my name there, so I have to do square brackets around it. And so now that I've created that sample data by clicking on the ellipsis, now I can test my query and I can see what the output of that query would look like. So we can see here we have so the record type, we have the time, the dates. I know somewhere in here is the country where the call was originated from. So that's just passing the data straight through. Now, if we want to do some analysis on this data, we can do things like call out the different query names. So again, we're going to do this and change this input name a little bit. And let's just run this one. And now we've just reduced our data set just down to the columns that we care about. So the switch num is going to be the country where the call originated from. So we just nailed it down to the calling num, the call end num, things like that. Now, taking that a step further, we're going to do a tumbling window example on this one. So with this one, we're going to just say, we copy and paste it out here so we can see this. We are going to select the timestamp is going to be our window end, the switch num, and just a count. And we're going to count that over a tumbling window of every 5 seconds. So basically, how many calls did we have every 5 seconds? We're going to test that query out one more time here. You'll notice, thankfully, this SAQL language is not case sensitive, which is a breath of fresh air. So there, again, is a sample output. So our query tested successfully, and we could use this with our job. And then finally, one more example to show you quickly is the self-join. So really what we're trying to accomplish today with this Stream Analytics is determining if there's fraudulent activity with the SIMs within our cards, within our calls. So what this is going to do is a self-join from the call stream. We have 1 and 2. Fix that one more time. We're going to self-join the 2 streams together, and we're going to find out where the switch num, so where that originating country, is not the same within 5 seconds. So this is telling us there's probably something wrong with this SIM. Somebody's probably stolen the SIM number or ID or something like that, because it's probably impossible for me to make a call in China and Germany within 5 seconds of each other. So go ahead and test this one out and see if this query works. Everything looks good there, so I'm going to go ahead and save this query now. So we have a fraud detection query available here now. So what I'm going to do is click save, and the changes you made will be saved. And I'm going to go back to my my Stream Analytics job. So now we have an input, we have a query. I know we're getting short on time here, so I'm going to go ahead and create an output. We have a few options for outputs. We're just going to call this fraud calls. We're going to dump it to a sink of an event hub. So I'm sorry, of a blob storage. So for what I want to do for the first piece of this output, what we have time for today is I'm going to take the data and dump it out to a blob storage. The other option we have here would be Power BI. If I pick Power BI, let's go ahead and just do Power BI. So I'm going to pick Power BI, and what this is going to do is create a streaming data set on the Power BI side, which is going to start streaming the data out there. I'll be able to see the number of fraud calls per country. We can create a report, something like that. If I picked the blob storage, it gives me options for what storage account do I want to put it in. So I'll put it in one of the storage accounts I'd like. And then we also have options for how to store the data. So we can break it up into folders by day and by hour, things like that with our path pattern here. For now, what I'm going to do is go with a Power BI. I'm going to say authorize, sign into Power BI, give this a data set name, stream fraud calls, and fraud calls. And I'm just going to click create on that. Give that a second to create. I'm going to go back to my Stream Analytics job. And now what you'll notice is that the start button, which was grayed out before, is now available. So to start a job, you always have to have an input, a query, and an output. You can have multiple outputs as well on the query. If you had multiple outputs, basically you would have to say, do a select into statement to say which output you would want that select statement to get passed to. So I'm going to go ahead and start this job. It does take a few minutes to start it. So I'm going to get that started up and let that streaming job start. And while that's running, I wanted to show you a few helpful links I'm going to share. So this tutorial I'm running through right now is actually available from docs.microsoft.com. So there's a demo out there for Stream Analytics real-time fraud detection. It walks you through in good detail all the steps that I'm showing you here. It actually takes the data and dumps it out to blob storage. So this is good. We're going to look at what it looks like when we go to a Power BI output. There's also a nice white paper out there for reference architecture that goes more in detail of all the different pieces that are that we're setting up here today, like event hubs and the Stream Analytics jobs, stuff like that. And then there's also just the straight up Stream Analytics documentation. There's a link there for that too. So like I said, I'll post this up to my blog, so this is available for everybody to look at and download and get a hold of those helpful links. Let's bounce back to our job. It says it's starting, so that's good news. Hopefully it starts here in another minute. And while that's starting, I'm going to go ahead and make sure I'm logged into my Power BI. So in Power BI, what this is going to do is it's going to create a data set. I didn't give it a workspace, so it's just going to go to my workspace because I was logged in. It's going to show up underneath my data sets here. So BGAL streaming calls is one that I set up for a completed lab. Hopefully here momentarily, if we keep refreshing this, it does take a few minutes. We'll see the data come in. So it did start successfully. That's good. It's up and running. It'll take a moment to create my data set. Now, one of the things it does with the data set in Power BI when you create this is it's actually using the REST APIs behind the scenes. So it's going to create a data set here, and it's going to start pushing data into that data set. And it's also set up to retain some history. So there's a couple different ways to set up a push data set within Power BI. It uses the push method, and it creates a small database behind the scenes for us that retains a small amount of history. So what it actually does is it creates a first in, first out scenario, and it's going to keep the first 200,000 records, and that's what's going to be available to this dashboard. Let's see if it created yet. There we go, stream fraud calls. So this is the data set within Power BI now. I could edit it. Probably don't want to edit this one because this is one that was created for us by Stream Analytics. I'm going to click on create report for this. And hopefully if all has gone well, what we're going to do is do a calling MSI. I'm going to turn this into a count. So we have a count of the number of calls we have. I'm going to look at switch 1. Oops, let's delete that off there. I'm going to add, I'm going to turn this into a bar chart, add this to switch 1. So this is the number of fraudulent calls we have per country right now. And the next thing I'm going to do is I'm going to create a line chart so we can see this data streaming. By the way, the app was set up to have like a 20% fraudulent call rate, so that's why there's so many bad ones. We're going to do, again, calling MSI. We're going to set up a count on that. Drag that down to values. Set up a count, and we are going to do time as our axis. So now we have a streaming data set of per country, the fraudulent number of calls we have. We can click on this. And I'm going to go ahead and save this report and call this real-time fraudulent calls. So now this will be available within Power BI. You should see it show up within my report list here, and it does. So if I click on that report, we'll switch over to reading view. So now I have an interactive report that is having data pumped to it. So as I refresh this, you'll see it's adding more data there. Let me edit this one more time. I'm going to go ahead and add a few options here so you can see, excuse me, so you can see the data and how it's coming in. This is a little too much data. This is showing every single record, but I wanted to show it to you so you could see the timestamps on these as they come in. It's every 5 seconds. So that tumbling window that we set up is how often the data is being displayed here. So we rolled it up to 5 seconds, and we're sending it out to this dashboard. Click reading view. I'm gonna go ahead and save that. So now we have a real-time dashboard showing our end users fraudulent calls that are coming in and where they're coming from. So that was what I had for our demo today. I did want to open up. I know we don't have too much time. If I don't have time to get to all the questions, Erica, I can try and get to a blog post to answer some of them, but we'll go ahead and answer some questions now.
Okay, we actually don't have that many questions here. I have one person that joined. Oh, we have some coming in now. I have one person that joined late and wanted you to explain what SAQL is.
Gotcha. So SAQL is a really good question. SAQL is a language specific to Azure Stream Analytics that Microsoft created for us to create the Stream Analytics job. So it's the language we use to create the analysis on the data stream. It's only for Stream Analytics. You'll also hear there's another SQL variant out there within Azure called USQL, and USQL is used on Azure Data Lake Analytics, so a separate product, another language. They're all trying to keep them all as similar to T-SQL as possible.
Okay, next question. I have a couple coming in now. How can I get data from Google Analytics to Event Hub to data Lake Store? What's the best method?
So there's a few options there. I'm not myself, I'd have to look. I don't know off the top of my head the best way for Google Analytics, but it depends on how you're pulling the data in. Whatever mechanism you're using to pull in, usually it's just a few lines of code to create a class or something like that that ties into your Event Hub and gets it into the Event Hub. So the Stream Analytics jobs have to have either a blob source or an Event Hub source. That's one of the requirements to use Stream Analytics over something like HD Insight Storm.
Okay, I have another question here. Can I connect an event input of S3 files?
So not directly, no. So that goes back to the requirement that it has to be either a blob or an Event Hub. So to use Azure Stream Analytics, you would have to come up with something to pump data into an Event Hub. So you could use something like Azure Data Factory to pull that data out of your S3 storage and pump it into Event Hub. That would go back to the Google Analytics as well. If we could develop a Azure Data Factory that would pump data through, that could be something we could do.
Okay. How do you incorporate a machine learning algorithm to the stream?
Gotcha, good question. I didn't have time to demo that today, but basically I can give you a real high level. Once you've created the web service with Azure Machine Learning, you can turn that into a function within the Stream Analytics job. There's a functions button within Stream Analytics job that lets you create that, and then it becomes an output to a query within the SAQL. So basically, we would use a CTE type setup. We're going to create a with SQL statement as this, where we call the function, and then we're going to use that CTE query in a secondary query. So it would be done within the SAQL statements that we saw today.
All right. How does ASL differ from, wait, I can't see this now, Kafka? Kafka?
So the difference between the two is basically this is a proprietary Microsoft version of Stream Analytics versus Kafka and Storm and all those are Hadoop open source. So Microsoft supports both, and so if you have the expertise to run the HD Insight or the Hadoop clusters yourselves, that option is available out there in Azure. What we saw today was basically Microsoft getting those tools closer to the skill sets that are primarily seen within shops that are Microsoft only shops.
What are the different output storage options?
So the output storage options, there's a lot there. Let's see if I have time to pop this open. Since it's running, it's not going to let me edit that. Let's see if I can get it to show me. So on the docs, they have all the different options. There's quite a few. You can go to Azure Data Lake Store, Azure Blob Store, Event Hub, Power BI. Those are the four most common ones that I've worked with. There's a few others in there. Those are the four most common though.
Okay. Let's see. Do you have any samples with Google Analytics? Any links or anything that you can share? I guess the person asking is Mithron.
I do not. I do not off the top of my head. I can make a list item and see if I can try and hunt down somebody who has that example. I don't have that demo available though. I can say though, if you're just trying to test it out, you can do that with Power BI, just direct connecting Power BI to Google Analytics. That would be real-time querying, not Stream Analytics like this, but it's another option for testing out Google Analytics.
Okay, that sounds good. I actually don't have any more questions here. So I'll go ahead and wrap up the webinar for you. Thank you everyone for joining our free webinar today. As always, I know a lot of you ask. We will be sending all registrants a follow-up email, including a link to the full recording of today's webinar. You can also find the recording on our website at pragmaticworks.com. I usually post that after lunchtime. So thanks again for your time, and we look forward to seeing you next Thursday, or this Thursday. We actually have a guest speaker for our partner webinar series, and that will be this Thursday at 11 o'clock, and we hope to see you there. Thanks, guys.
That's good. Thanks, everybody. Bye.